Dear children, so let me continue with the last session. So the compounds means it's a pure substance made up of two or more elements which is combined chemically in the definite ratio. Definite ratio means it's having the fixed ratio. So there are some characteristics of compounds are there. The properties of compound differ from those of its constituents. So every properties of compounds are depends upon this constituents, and compounds have fixed melting point and boiling point because it's having the fixed ratio, fixed composition is there now, so it's having the fixed melting point and boiling point. For example, you can take water. So water is the example for compounds. So what is the melting point of water? Yes, 0 degrees Celsius. It's fixed. And what is the boiling point of water? Yes, it's 100 degrees Celsius. It's also fixed. So the compounds have fixed melting point and boiling point. And next, compound is a homogeneous substance. So compound is a homogeneous. Homogeneous means it's having the same phase. Single phase is there. So you can see the water. So in water it's having single phase. Same phase is there. So no uniform, no non-uniform composition is there, no? And so constituent elements can be separated by chemical process. So in compound, for example, water. So in what is the formula for water? H2O. So by chemical process, we can separate the compounds into various elements. So the H2O can be separated by hydrogen and oxygen by chemical process. And next is mixtures. So mixtures can be classified into two major types. One is homogeneous mixture and another one is heterogeneous mixture. So it is made up of two or more elements or compounds mixed in any ratio. So compounds means fixed ratio. Mixtures means any ratio. The ratio is not fixed in mixtures. The properties. So the mixtures, it may be homogeneous or heterogeneous. Homogeneous means single phase. Heterogeneous means different phase. Next, the properties of constituent substance are retained. And no new compound is formed. So with that mixtures, no new compound is formed. So the elements can be separated by simple physical process. It can be easily separated. And it does not have a fixed melting and boiling point. So the mixtures will not have the fixed melting and boiling point. Let me do one activity. So with the mixtures concept. So the activity is, let us divide the class into groups A, B, C and D. So we have to divide the classes with the four groups A, B, C and D. Group A takes a beaker containing 50 ml of water and one spatula full of copper sulfate powder. So first group A, they have to take one beaker. So in that beaker, they have to add 50 ml water. They have to add 50 ml water they have to put one full spatula of copper sulfate. They have to put one full spatula of copper sulfate in the 50 ml of water. So they have to dissolve it. And the next group B takes 50 ml of water and 2 spatula full of copper sulfate powder in a beaker. Group B, they have to take another beaker. With that they have to add 50 ml of water and they have to add 2 spatula of copper sulfate. 2 spatula of copper sulfate. You have to add 2 spatula of copper sulfate. See here, so in first beaker we have to add 50 ml water and 1 spatula of copper sulfate. So we can see the solution here, copper sulfate solution. It's homogeneous or heterogeneous, children? You can see it's in the uniform distribution is there, no? So it's homogeneous. You can see here. Here also it's homogeneous. But the beaker A, its color intensity is low. In beaker B, the color intensity is high. Because here we add only 1 spatula. In the beaker B, here we have to add 2 spatula. So the beaker A and beaker B is a homogeneous mixture. And next, is group C. The group C we can see, that is groups C and D can take different amounts of copper sulfate and potassium permanganate or common salt, that is sodium chloride, and mix the given components to form a mixture. So group C, they will take one conical flask. So in that conical flask they will add 1 spatula of copper sulfate and 1 spatula of common salt, that is sodium chloride. So it's a mixture. It's a mixture. And group D, they also take one conical flask. So in that conical flask they have to add 2 spatula of copper sulfate, 2 spatula of copper sulfate and 2 spatula of common salt. So it's a mixture. So you can see here. So it's a beaker C it's a group C and it's a group D. So both we can see here, it's uniform composition or non-uniform composition, children. So it's uniform or non-uniform? Yes, it's non-uniform. It's having the different phases is there. You can see here, it's having the different phases. The copper sulfate salt is also there and common salt is also there. The white color, you can see here, no? The white color. Yes, the white color is the common salt. And that blue color. So blue color is the copper sulfate. So here it's not in the uniform composition. So we can tell it as group C and group D. They are having the heterogeneous mixtures, not homogeneous mixture. And report the observations on the uniformity in color and texture. So the observation is group A and B have obtained a mixtures which has a uniform composition throughout. Such mixtures are called homogeneous mixtures. So you can see here, so group A and group B. So these mixtures are uniform composition. So that we can tell it as these group A and group B, they are having the homogeneous mixtures. And some other examples of such mixtures are salt in water and sugar in water. So we can tell it as homogeneous mixtures. Examples, that is, we have to add salt in water or sugar in water. And when we compare the color of the two solutions of the two groups, though both the groups have obtained copper sulfate solution, the intensity of the color of the solution is different. So both group A and group B are prepared the copper sulfate solution, but here the intensity it will be different, because in group A they will add only one spatula of copper sulfate. In group B they are added 2 spatula of copper sulfate. So in group A the color intensity is low when compared with group B. And next, this shows that the homogeneous mixtures can have a variable composition. And next, group C and group D have obtained mixtures. They contain physically distinct parts and have non-uniform composition. You can see here. So it's a non-uniform composition. You can see here. So here you can see the white particles. The white colored particles. This white colored particle is what? It's a common salt. And the blue color it's copper sulfate. It's a non-uniform composition. And such mixtures are called heterogeneous mixtures. So mixtures of sodium chloride and iron fillings, salt and sulfur and oil and water are examples of heterogeneous mixture. So the group A and group B are prepared the homogeneous mixture solution. And the group C and group D, they are having the heterogeneous mixtures. So homogeneous means uniform composition. Heterogeneous means non-uniform composition. Okay children, see you on next session. Thank you.